section 14.6, the pH scale. Go check out video problems 82 through 89. Lots of video problems because this is sort of a big topic that we see is pretty important in AP. It's one of the big main ideas. So typically we express hydronium ion and hydroxide ion on the pH scale. Now you think of it running from 0 to 14, but it can actually, you can have negative pH and you can have a pH greater than 14. Okay, just in everyday life you don't run into those too often, but here in the lab we do. Right? So what's neutral? Well, pH of 7 is neutral. Anything below 7 is acidic. Anything above 7 is basic. So, and you probably knew that already, but 0 up to 7 is an acid. 7.00 is neutral. And then 7 to 14 is your base. Alright? So what are some common acids and bases? You can take a look at this and see. Milk, a lot of people think that milk is a base. It is not a base. Milk is slightly acidic. Seawater slightly acidic or slightly basic, and it's becoming slowly more acidic as it absorbs more and more CO2, which is a bad thing, obviously. Right. A lot of your cleaners are bases. Right. All right. So what do we have to do to calculate pH? Well, pH is negative log of the hydronium ion, the concentration. I often write it as pH is equal to negative log of the hydrogen ion, same thing. So as long as we know the concentration of the hydrogen ion, we can calculate the pH. Okay, it is an inverse or a negative log value. Real quick about logs, and as far as significant figures, the number that comes before the decimal in a log, so in this case pH, it's not a significant figure. So only the decimals are counted as significant figures. Okay? So, and you'll see that when I go through the problems. So here's how I'm going to calculate pH. Again, as long as I know the concentration of the hydrogen ion. Well, if it's a strong acid, then typically here HA is just a generic acid. A strong acid, one-way arrow, let's say this is 0.75 molar, then this is going to break up like this, so this will be 0.75 molar as well. Okay, for a strong acid. Now, for a weak acid, though, we can't do that. Right? So here's a weak acid. We know that it's in equilibrium with H plus and A minus, and we said these two are equal, and this is by itself, but we can't go left to right here. We can't use stoichiometry like what we did over with the strong acid. Right? We have to use the equilibrium expression to be able to calculate this now. So this is going to be Ka. Okay, and you'll see that when we go through the video problems. Alright? So there's how to calculate pH. If we're given hydroxide, one way that you can get to pH, remember, you know, pH is negative log of that hydronium ion. So if we're given hydroxide instead, we can use this equation, Kw is equal to hydronium ion times hydroxide. Is what we just saw, right? Which is equal to 1 times 10 to the negative 14th. We just had a section on that. So you're given this value, this is some number, this is your unknown x, and it's equal to 1 times 10 to the negative 14th. Solve for x. Okay? Now there's other ways to do it too, and I usually do it other ways. We can also calculate the pOH by just taking the negative log of the hydroxide. Okay? Generally, P in front of something that you recognize means negative log of that something that you recognize. All right? So for instance, there's something called pKa, and that's the negative log of the Ka. Okay? Alright, so back to this. We can calculate pOH by taking negative log of the hydroxide, and then there's this relationship that pH plus pOH is equal to 14. So that's the one that I typically use. Like if I'm given hydroxide, I'll calculate pOH, and then I know that pH plus pOH is equal to 14. So I think it's a lot easier to calculate that way. Okay. What if we want to calculate hydronium ion. So in other words, we are given this pH value, but I want to know what is the concentration of the hydrogen ion, or hydronium ion. I'm going to use this equation. 10 to the negative pH is the hydronium ion. Right? And that just comes from this equation. Okay. To get rid of a log, you take it to the base 10. So that's actually it's both. Let's put the negative on the other side. So negative. Get rid of that. Right. Right. Take it to the base 10. Get rid of the log. So it's 10 to the negative pH is equal to the concentration of the hydronium ion. So that's where that comes from. Okay. So if I want to know the concentration of the hydronium ion, I can use the pH. And same is true for the pOH. So if I want to know the concentration of the hydroxide, I can say 10 to the negative pOH is the concentration of the hydroxide. Alright? But go and look at all those video problems and you'll figure it out.